Hello, this is Math with Beth, and we are going to be using the quotient rule to find derivatives, but with these application problems involving cost and revenue and profit. So if you have not already watched the video on the product and quotient rules, you definitely should watch that first, because I'm going to assume you know how to do the quotient rule before you do this. So this is just explaining that if C of X is the cost of producing X terms, then the average cost of producing X items is C of X divided by X. So this is just a special equation when trying to find average cost. And it makes sense because when we find the average of anything, we add up everything that we have and we divide by how many things we have. So that is what the X is in this problem, how many items. So average cost would be the cost equation divided by X. To find average revenue, revenue is how much money the company brings in. You would use the revenue equation divided by X. And then finally, for the profit, which is how much you actually make, you would take the profit equation divided by X. But more importantly, if they don't give you the profit equation, remember, it is your revenue minus your cost. So in order to find the profit equation, you might need to take the revenue equation minus the cost equation. But then to find the average profit, divide that by X. So this is just some applications. Let's try one. The average cost. Let's say Men's Warehouse finds that the cost in dollars of producing X belts is given by this equation. So this is our cost equation. Find the rate at which the average cost is changing when 175 belts has been produced. So there's a couple key words here. First, they mention average cost. So remember, we just learned that we need to do that to find the average cost. But then they talk about the rate that it's changing. Whenever you hear something about the rate something is changing, that's your key that you're going to need to do derivative. So first, let's set up the equation for average cost. So we take our cost equation and divide it by X. So this is our average cost. But now, since they didn't just want to know what the average cost was, they wanted to know the rate it is changing when we have 175 for the X, we need to find the derivative. So the derivative of this, I guess let's just call it Y prime. We're going to need to use the quotient rule. So hopefully you already know how to do the quotient rule, which means we have to take the bottom function times the derivative of the top function, which in this case would be 0 plus 34 minus, we need to multiply the 2 here, x. So this is the bottom function times the derivative of the top minus the top function times the derivative of the bottom function, which in this case is just 1. So we don't even really need to write it, but there it is. And then don't forget, for the quotient rule, you then divide by the bottom function squared. So this is my derivative. I could spend some time trying to make it nicer, but if at the end of the day they want me to plug in 175, I can be lazy and just plug in 175 right now, but I just need to be super careful when I do that. So maybe I'll make the top a little bit nicer by distributing the X and distributing this negative just to make it easier to put in the calculator. So I'm now going to plug in 175 for all of my X's because that's what they wanted me to find. The rate of change, which means the derivative at 175. So I'm going to carefully plug it into the top first And then I'm going to divide that by the bottom. And I got negative 0.22848. So it depends on what they want you to round to. But that is the rate that the average cost is changing when 175 belts have been produced. Let's try another one. Average revenue. So this time I have a equation for revenue, and then want me to find the rate again, which hints for derivative, at which the average revenue, which means I have to do this first, is changing again when we have 175 belts. So first step, make my equation for average revenue. Second step, find the derivative of that. So again, I need to use the quotient rule. Bottom times derivative of the top. So I need to do 45 times 9/10 times x to the 9/10 minus 1, which is that, minus the top function times the derivative of the bottom, which again is just 1. So I can leave it like that, all over the bottom squared. So again, I can do some of the math here to make it a little nicer before I put it in my calculator. But basically, you're going to make it as nice as you can, and then you're going to go ahead and plug in the 175 for the x's. And in this case, you should get something around this. Again, it depends on what we're rounding to, but because it's a rate, it's this much money per belt. So basically, the more belts we make, we're actually losing more money. So there's probably a perfect amount of belts that we should make to make the most amount of money. Finally, let's do one with average profit. So this is a different example. We have Sparkle Pottery, and they have determined that the cost in dollars of producing X number of vases is given by this equation. So here's our cost. If the revenue from the sale of vases is given by this, they now want us to find the rate, hint that we're going to do a derivative, at which the average profit is changing. They did not give us the profit equation. So the first thing we have to do is remember that the profit equation equals the revenue minus the cost. So in this example, it would be the 65 times x to the 0.9 minus the cost, which is all this. So that is our profit. And since they want the average profit, we again need to divide by x. So this is our equation for average profit. But now they want us to do the derivative. So first, I'm going to go ahead and just distribute that negative. And now I'll go ahead and use my quotient rule, which tells me to do the bottom times the derivative of the top. So I need to do 0.9 times 65. X to the 0.9 minus 1. The 4,300 is going to go to 0. And then minus 2.1 times 0.6. X to the 0.6 minus 1, which is negative 0.4. So that's the bottom function times the derivative of the top minus the top times the derivative of the bottom, which is again going to just be 1. All over the bottom squared. So We can try to make that as nice as possible. But basically our final answer, if we plug in the 50 for all of these x's carefully, would be this. Again, we're losing $1.64 per vase. Actually, I think if I did that more carefully, it would end up being positive for this example. Sorry. So just try it, but the trick is find your profit equation first by doing revenue minus cost, divide it by X if they want you to find the average profit. And then if they ever mention anything about rate, we're doing derivatives. So in these cases, it's always going to be using the quotient rule. So hopefully that helps. If you need more help than that, please reach out and let me know.